Okay, I want to continue our discussion of existing cellular systems. So we're going through each of the different generations of cellular service. So last time we talked about AMPS, which was the first cell phone service provided by AT&T. It was an analog service that used frequency division multiplexing for the different channels. A subsequent iteration of AMPS actually time domain multiplexed multiple users on a channel, but it was still used frequency modulation for analog voice. Subsequent generations all sampled the voice channel and then transmitted it digitally. Subsequent generations moved more and more toward handling actually digital data and doing everything with bits, with binary data, instead of transmitting any sort of analog data. So there were two primary second generation systems that were in use. GSM was actually developed in Europe, um, and it stands for, let's see, Global System Mobile. In the U.S., it was used by AT&T and T-Mobile carriers, and it's used actually kind of primarily throughout the world outside the U.S. Um, at the same time GSM was being developed, there was another second generation technology, CDMA, which was being offered by a company called Qualcomm. And then that particular system was used by Sprint, Verizon, and US Cellular. So in the US, we had these two competing technologies, which made it difficult to take a phone from one carrier to perhaps another carrier. GSM phones actually had more widespread use because they were used actually throughout Europe. I mean, GSM was primarily developed as a standard for all the European countries, so that users could easily, roam throughout Europe and still be able to use their phone. Um, both GSM and CDMA are kind of being phased out as we move now into subsequent generations, which we'll talk more about. 3G, 4G, and then now 5G, which are supposed to be standards, and in some sense they are, but because the different cellular service providers may use different frequency spectra, doesn't mean that you can still easily take a phone from one service provider to another. There are some phones that are manufactured by different companies, like I think the Moto has a series that operates across several. Motorola has a series that operates across several different providers, as does Google, and then I think the latest iPhones actually support all the major carriers. So this is a long section of the book. I'm going to break this up into a couple different short videos. But let's get started looking at GSM. I want to first look at, in this section, the different frequency bands and channels, the frames, the identity numbers, and then the interfaces and layers of GSM. So GSM actually used frequency division multiplexing. So they had different frequency bands, but then also time division multiplexing of 8 different users within each frequency band. So again, we'll look at the different frequency bands and channels, and then look at the frames, and then the identity numbers, and then layers. The GSM infrastructure is similar to the AMPS. There's not actually much change in between the backbone network, which is the from the mobile switching center, what changed is actually this support at the base station controller. The BTSs here are the base station base transceiver stations. This is where all the electronics are to actually support the different frequencies that are used by GSM compared to AMPS. So, of course, all of this equipment is highly specific to the particular frequency channels and how the data frames that are used in GSM. And they show here different base transceiver stations, all supporting the different frequency channels that make up all the available channels in GSM, all tied into the base station controller, and then that base station controller will be tied into the mobile switching center. The mobile switching center actually may have may actually control several base station controllers. We'll talk a little bit about these interfaces a little later on. You'll see this terminology. And then the mobile switching center is responsible for tracking these different registers that keep track of where the mobile phone is, what particular cell it's located at, so it can actually forward traffic to the proper cell as the user roams between cells. And then there's a gateway mobile switching center that then provides the interface to the public switch telephone network. And again, it's the public switch telephone network which is responsible for routing the phone traffic across the country as you make your cellular telephone call. So the traditional phone system is still heavily used that backbone network. It's the last mile network, the connection between the home, the copper connection between the home and the local switching center that is actually being phased out as people move to mobile. So I think I've talked about a lot of these. Some of these we've talked about in the past. We'll talk a little bit about authentication method a little bit later on today. But the mobile switching center has all these different registers to keep track of the different phone equipment and users that are actually in a particular service provider's database. So the frequency bands used by GSM. So for the uplink or reverse channels, this is for mobile station to base station, used one set of frequencies from 890 megahertz to 915, and then another set of frequencies were used for the downlink. What is this? 25 megahertz was divided into 124 uplink channels and then 124 downlink channels, so we could have full duplex communication. Each of these channels was actually further multiplexed into 8 time domain multiplex channels. So supporting in each cluster then 8 times 100 or 124 or approximately 1,000 different users in a particular cluster. There are several logical channels in GSM, so this is actually how the bits are divided up into different ways. So these aren't specific, don't correspond to specific time slots or specific frequencies, but just how the bits can be streamed out, separated out into different what are called logical channels. And several of these are available. Some are for the control channels, and then the voice traffic takes place across the traffic channel. There's actually 2 traffic channels available. I think the full rate traffic channel is like 13 kilobits per second. And then the half rate channel was half that. At the half rate channel, the voice quality wasn't as good, but it used a lot less power. So if your phone was low on battery life, you could switch to half rate quality and get extended life with the phone. So a little bit more about these different channels. The broadcast control channel transmits the system parameters like the frequencies of operation in that particular cell, the operator identifiers. There's a frequency correction channel for transmission of frequency references and frequency correction burst. A synchronization channel. There had to be synchronization between because we're using time division multiplexing here, so each mobile system has to actually be synchronized to the corresponding base station to transmit data in the right time slot. There's different control channels between individual mobile stations and base stations. The three previous control channels broadcast information to all mobile systems, but then there were some that were set aside for just communication between individual mobile systems and the base station. There's a random access channel used by the mobile system to transmit information regarding the requested dedicated channel. There's a paging channel. Again, paging refers to connecting to a mobile system to receive a call, and then an access grant channel used by the base station to send information about timing and synchronization. Other channels could be used for any control information transmitted while the communication is ongoing. There's what's called a slow associated control channel, which is allocated along with a user channel for transmission of control information. Standalone dedicated control channel for transfer of signaling information. So this would be like hang up information. Fast associated control channel, not a dedicated channel, but carries duplicate information as the SDCCH, but it's part of the traffic channel. Okay, so here's showing the layout of various frames in GSM. The basic TDMA frame consists of 8 slots corresponding to the 8 time division multiplex channels, and then TDMA frames are arranged into 25, a group of 25 frames called a multi-frame, and then 51 multi-frames form a superframe, and 2048 superframes actually form a hyperframe. So some of the individual frames would carry the information for all the various control channels. So channel 0 here would be set aside for use by the different control channels on certain frames within the multi-frame and corresponding superframe. And then the other frames were actually used exclusively for user data. So this shows a little bit more about this particular slot, one of these particular 8 slots here, the structure of a TDMA frame. The entire frame consisted of, was approximately 4.6 milliseconds in length. If you divide that by 8, you get the 0.577 milliseconds for an individual frame. An individual frame actually consisted of 156 and 0.25 bits. Of course, it didn't actually consist of a quarter bit. It was actually a quarter bit of time. There was actually a guard time that was 8 1/4 bits in length between successive slots. And then an individual slot really contained 116 different data bits. There were start bits and stop bits, and then right in the middle there were 26 training bits allowing synchronization between the mobile system and the base system for the individual time slots. Okay. There are a number of different several different numbers that are associated with a GSM mobile phone, which, and all these numbers together uniquely identify the phone, the country, um, the mobile system, the service provider, and actually even which cell that the mobile phone is currently residing in. Um, uh, so the first of these is the International Mobile Subscriber Identity, or IMSI. It has information again about the country. It has the mobile system identification code. Um, it also is used to locate the particular visiting location register, and find out the subscriber's home um, mobile switching center. This number IMSI is actually stored on the subscriber identity module, or the SIM module. These SIM modules were used by GSM, but not by the other competing plan, the CDMA. SIM was kind of a neat technology. All of this information actually resided on a card instead of being hardwired into the phone. So you could easily actually switch phones with if you were if your cell phone provider used GSM, by just moving the SIM card to a new phone. It even made it possible to actually you could take your SIM card out of your current phone, travel to a different country, get a GSM phone there, and put your SIM card in, and then immediately use the phone. Whereas with CDMA, there wasn't a SIM card. All the cell phone identification was hardwired into the phone. So if you wanted to actually switch to a new phone, with CDMA, you had to contact your service provider and give them the information about that new phone to make that connection. With GSM, you didn't have to do that. It was all just based on moving the SIM card to a new phone. So here's the format of the IMSI. Consisted of a 3-digit country code, 2 digits to identify the mobile network within that country, and then a mobile subscriber identification code, which was not the phone number actually, but assigned to you by your service provider. So information contained on the SIM. SIM could contain um, subscriber specific information, such as you could actually use the SIM. It had extra memory on it, so you could actually use it to keep a list of phone numbers, or your personal identification. You could actually store short messages on the SIM card. Again, it was a plug-in module that you could transfer between phones. And then it also allows you to support roaming, in the sense that you could just pull your SIM card out of a phone in one country and put it into a temporary phone, or a borrowed phone in another country, and then immediately connect to the network. The mobile system ISDN is actually where it consisted of 15 digits or less, and this is essentially your phone number. It consists of a country code, a national designation code, and then your actual subscriber number. Okay. There's also a location area identity that was used to actually route calls from your home network to the current location of your cell phone. And so the location area identifier consisted of a country code. Again, remember that GSM was actually developed in Europe, so it was quite common for users to roam between different countries. And so calls may have to be, if the user was actually from Britain, but we're currently in France, the call information would be routed from their home switching center in Britain actually to wherever they're currently located in France. And then that was done using this location area identifier to indicate where the user currently is. So again, it consisted of the mobile country code, the mobile network code, and then the subscriber identification code. And then this information would be used to actually route the data from the home location to the current location of the mobile system. There's also the international mobile system equipment identity. It's commonly just called the MSEI. And this can't be changed. It uniquely identifies a particular phone. Sometimes if you're working with your service provider, when you're first connecting your phone to a new service provider, they will ask for the MSEI of your phone, because this should uniquely identify the phone. Every manufacturer would put different serial numbers on the different phones that they produced. And then a mobile station roaming number. It's allocated on a temporary basis when the mobile system roams into another numbering area, a different country, a different destination code. It's used by the home location register for rerouting the call. There's an international mobile subscriber identity, which again is closely associated with your phone number and is permanently assigned. For security purposes, the users actually assigned a temporary mobile subscriber identity that's used over the air interface between the mobile system and the base system. Okay. Again, a lot of different layers in the GSM system, and so a number of different interfaces have been defined between the mobile switching center and the visiting location register. So these interfaces have been assigned different letters. The bottom group here marked map are all between the mobile switching center and other various entities that make up the network. This diagram shows the location of these interfaces between the mobile system, and then this is the base transceiver system. So that's called the interface. And then this shows the corresponding layers that are part of this interface, and most of these are actually physical layer interfaces, going back to that OSI network model that we talked about previously, and the different standards that apply in each of these interfaces. Then there are different functional planes that make up GSM. The physical network, there's a plane for managing and allocating radio resources, like what channels to use. Mobility management layer for handling roaming. Communication management for managing the quality of the call. And then operations and administration layer for managing the entire GSM network. Okay. The authentication process to authenticate or prove that a mobile station has access to a particular network is handled like this. So the network actually has a database of the user's IMSI and then actually a particular key that's assigned to the phone. The telephone network would actually generate a random number and send that across to the mobile station, and then that random number and then the IMSI and key are all fed into an authentication algorithm. The mobile system actually runs these three numbers through the same authentication algorithm to produce a response that's compared to the response that's calculated by the fixed network. And then, if they agree, then that means that the mobile station does have access to the particular fixed network. You know, if they don't, if there's some difference in the IMSI or the key, then the phone won't be given access to the network. Okay, I think this is the first part of today's lecture, so I'm gonna stop here and take a little break before we go into the next section.